say make we talk about the small things, so. Forget about the big things, so. Say make we talk about the small things, so yeah.
Hello, my people out there. Welcome to the program Edu Radio. Edu Radio is your top magazine program where they committed to inform you and enlighten you on the troubles that our education don't get over time. Edu Radio today, they with your team leader will be Oman Dave. Now me be the team leader. Others then they behind, and then they give me the backup. Even due drop with the stream this thing where they hear like this. Now the guys when they behind the screen. Welcome to the program once again. Today on the program, as usual, and we'll stop to talk so we don't keep our program aside, just to bring education to the fore. What do you do? What has been your contribution? Now just to sit down and watch television 24 hours 7, you come up from Al Jazeera, you enter CNN. From CNN, you enter channels. From channels, you enter NTA. Have you taxed your brain on what to do? Have you taxed yourself? Have you asked yourself, what am I going to do? Because the times ahead, they're going to be tougher. For better economies, or better economics of the world, you don't prepare post-pandemic experience, what we will face, how we will face them, how we will overcome them. It no go easy. Begin package yourself. We don't package ourselves. For sake of say, we they add value, we they contribute. Today, we still get another lecture. Will be physics. I've been at physics 2. I've been at physics 3. Enjoy as our teacher will come teach you. Just enjoy. But just know at the back of your mind, say, Edu Radio, they're in partnership with you as a stakeholder in the educational sector. Because if you feel like when they talk, say you don't attend the height, your brother's uncle picking child is there. Your sister, auntie's picking child is there. Or your own picking uncle, or your own picking uncle. Check out. Enjoy the lecture. Physics teacher, over to you.
Hi, listeners and viewers out there. My name is Bisala Vincent Tanko. You're welcome to Edu Radio. We are here to learn a subject, physics, today in our episode. And in case of feedback or questions, you would like to reach us via our handles, Twitter, Facebook, Instagram, or email address or phone numbers as we give you your replies. Thank you. Now, we are looking at a topic, a very important topic in physics, which is work, energy, and power. Work, energy, and power. For those of you in SS1, SS2, SS3, preparing for exams, this is a very essential topic as well. So I call your indulgence so that you do this and listen, follow us and listen to us effectively. Now, let's look at work. Work. Everybody has different concept when it comes to work. Some people say, I go to work. Some people say, I work hard. Some people say, you need to work this out. And in different ways like that. But in this context, work is only done when a force is applied on a body and it moves through a distance. Without this, then work is not done. Now, if you pick up a bag of rice, for example, and put on your head and you stay for hours, as far as this topic is concerned, you have not done work yet. The only work you did is you picking that bag of rice to a height, down to your head. But whereas you have done nothing. Now, work is the product of force, the product of force and distance. The product of force and distance, which is giving us W, which is work, is force times distance. Now, if you will remember, force, or if you will recall from your previous classes in school, force is MA, meaning mass times acceleration. But when it has to do with a height, then you say mg. Then this distance we are talking about, is represented as s in physics. But when it has to do with a height, then you'll use h, meaning that work, which is W, can now generally be called mgh. That is, work is proportional to mass times acceleration due to gravity times height. Now, if you are given a question, for example, a boy of mass 10 kg climbs a set of steps of total height, maybe 3 meters, and then what is the work done against gravity? A boy of this mass climbed a set of steps of total height 3 meters, and then you are asked to calculate the work done against gravity. This is what to do. You already know that your work is equal to mgh, work done, which is mgh, meaning 10 times g, which is 10 meters per second square, always given is a constant, times 10 times 3. Now we can have 10 times 10 times 3 will give us 300 joules. The unit of work done is in joules. That is that about work. The questions under this context are relatively simple, but let us combine it. I will move ahead by saying energy. What is the concept of energy? Energy, we say, is the capacity to do work. We already know this definition, if I'm not mistaken. Now, energy is the capacity to do work. If you say so, fine. We have different forms of energy, formed from chemical, electrical, mechanical, nuclear, and so on, solar, different forms of energy. But in this context, we are going to be looking at mechanical energy because a movement through a distance is involved here. So looking at that, we have to look at mechanical energy because that is what is essential for this context. Now, mechanical energy, we have two types, which is potential energy, and then kinetic. Now, potential energy is the energy possessed by a body by virtue of its position. And we will say that potential energy is dependent on the mass of a body, acceleration due to gravity, and the height in which the body is. These are the parameters in which potential energy is dependent on. Without height, then potential energy is absent. Now, let's consider kinetic energy also. Kinetic energy is the energy possessed by a body by virtue of its motion. Now, Ke is dependent on the mass of a body and the velocity or speed to which the body moves, which is half mv squared. Now, let us check where this mechanical energy is transformed from one form to another in between potential and kinetic energy. Now, let's look at a body falling freely from a height, from rest. Let's say this body is falling. From this point where this body starts falling, before it starts falling, possesses only potential energy because there was no motion there. Possesses only potential energy. Kinetic energy at this point is 0 because the body is at rest from that height. Now, as the body drops down, getting to this middle, it is moving, which means kinetic energy is also involved. But it also has potential energy as well because there is still a height, meaning that here it has potential energy as well as kinetic energy. Now, as the body gets down to this last point on the ground, this body possesses only kinetic energy. Potential energy below, down here, is 0. But up here, kinetic energy is 0. But at the middle, potential energy and kinetic energy is involved. Another principle of this transformation we are going to look at is of the simple pendulum. The simple pendulum also transforms this same energy. Assuming we have this as our simple pendulum. Now, at this point, before the motion starts, of course, potential energy is here. Then, when it swings and gets to this point, it will rest for some few minutes, or few seconds, excuse me. Now, few seconds for resting here, we have potential energy. Here also, we also have potential energy. But at this point, as the motion goes on, we have KE here. We have KE here. So kinetic energy is high in the middle as far as motion begins in this system. Meaning that potential energy will be converted to kinetic energy will be converted to potential energy, and so on. Now, we can as well say, okay, in that instance, it simply means that PE is equal to KE. That is, your total potential energy is equal to your kinetic energy. Why? Because the potential energy your body stores to begin motion is the same energy that body will use to progress in motion. Now, if we have a question that says, let's have an example for instance, like a body of mass, 10 kg falls from a height 5 meters. For instance, calculate its potential energy and kinetic energy. Calculate its potential energy and kinetic energy. Now, if you have a question like this, it's very simple, of course. We already know that PE, which is potential energy, is equal to mgh. Now, what is the mass of this body? 10 kg. Now, all right, always like I've said, don't forget, G is always 10 meters per second square. We can have 10 here, and then the height to which it fell is 5 meters. 10 times 10 times 5, we have 500 joules. Don't forget, this question is just asking you to repeat the same thing. Now, calculate the potential energy and kinetic energy. Already we know that by virtue of energy transformation using a simple pendulum, that potential energy is equal to kinetic energy. You can therefore say KE. You say, but PE is equal to KE. That is, KE is equal to 500 joules as well. I believe this is clear. Now, if you are further given a question, for example, like, okay, let me use from here. What if they say, calculate the total energy from this question? Assuming they say, calculate the total energy. Calculate the total energy of the body when it was at a height of 3 meters. Yes. Okay. When it was at a height of 3 meters. Now, you already know that from the principle of falling bodies, a body falling freely from rest, when a body has not really landed on the ground, the energy is PE plus KE. Now, so let's go first. So if we say PE, which we know is equal to mgh. Now, m is 10, g is 10 as well, times, now they said 3 meters, so we say 3 is equal to 300 joules. We already know that potential energy is equal to kinetic energy, which is very, very true. There's no need to progress by doing anything. But this time around, the body possesses both potential and kinetic energy, meaning that we should have 300 joules plus 300 joules, meaning 600 joules, because it possesses both kinetic and potential energy at the same time. Do stay back. We are coming back shortly after the break. Thank you. All right, welcome back. Now, before we went for the break, we dealt with work and energy. Now, let's see power. Power. When two people try to run a staircase, for example, maybe a little boy and a grown-up man. The man will run faster, I believe, and the boy might run slower than the man in comparison. But what happened is that you will end up concluding that this man has more power than this boy because he will use less time in climbing to the peak than the boy. So in that regard, power can simply be the rate at which work is done. It is energy expended per unit time. That is, it is still put this way. Power can still be work done all over time. That is, we can say work done over time is known as power. But in definition, you can say power is the rate at which work is done. So we can still say energy expended over time. You are still defining power. Now, the unit of power, the unit of work done and energy is, they are all in joules. But power is in joules per seconds. Even though it is called watts, but because we are not dealing with electricity here, we can excuse that. But these two units are still units for power. Now, if you have this, simply, that is just power. That is all about power. So, for example, you are given a question like, a boy runs up a hill in 30 seconds. Calculate his mass if the power used is, let's say, 50 joules per second, and the height is, let's say, 10 meters. Yes, a boy runs up a hill in 30 seconds. Calculate his, I've jumped that. Calculate his mass. Yes, I was to look for his mass. Calculate his mass if the power is 50 joules per second and the height is 10 meters. Very simple. Power is equal to mgh over time, which is t. Now we have the mass there already. We have acceleration due to gravity to be always 10 meters per second square. Acceleration due to gravity to always 10 meters per second square. And then height is also given 10 meters. And then we are not given the mass, which means we should find the mass. Now let's do this. So power is already given. Power is, okay, if the power is 50 joules, yes, 50 joules. So we have 50 is equal to m times 10 times 10 over 30 seconds. Now, well, we can just simply put this way, and then let's cross multiply. 3 times 50, of course, is 150. Then we have 10m at that end. We are dividing both sides by this 10 in order to find the mass of this boy. M, which is the mass, is equal to 15 kg. 15 kg. That is the mass of the boy. At this time, you're given the power, you're given the height, you're given the time, but not given the mass. So you're expected to find this mass. Now, don't forget that I said, or if I have not said before, just note that 1,000 grams is equal to 1 kg in terms of conversion. Also, I told you here that watts is a unit of power. Also note that 1,000 watts is equal to 1 kilowatt. So if you are given the units in different forms, please make sure that you convert every unit to rhyme. In physics, if the unit doesn't rhyme, I'm not sure you're getting an answer. So you should try to make sure all your units are corresponding to the SI unit or the units of whatever it is that you are looking for. Now, if we are to continue with a question, let's solve one more question. Let's solve one more question. Let's say a body of mass 12 grams falls freely from a height of 10 meters. Calculate the kinetic energy. Calculate the kinetic energy of the body. Calculate the kinetic energy of the body and the velocity with which the body hits the ground. So in this question, quickly, so we have already the mass, which is 12 grams, which I said you should take note of the units. Now 12 grams, that grams is supposed to be in kg. So we should have mass equal to 12 over 1,000, please. Then we already have a height, which is 10. Don't forget, your acceleration due to gravity is always 10 meters per second squared. 10 meters per second squared. So we have this 10 meters, we have g already. So we all know that, okay, all this variable given, it is for potential energy. So let's check for potential energy first. mgh, which is 12 over 1,000 times 10 times 10. Yes, g and then height. So we have this 0, can cancel that, this cancel. So we have 12 divided by 10 now. We have 1.2 joules. 1.2 joules, that is the potential energy. We also know that potential energy is equal to kinetic energy. We can as well say, okay, PE, but PE is equal to what? KE. If PE is equal to KE, we can as well find the velocity. Even though we already know that PE is equal to KE, then we can say, all right, that simply means that KE is equal to 1.2 joules. We have found our kinetic energy as well. So we can now find the velocity by saying KE is equal to half mv squared. So we already have 1.2 as the KE. The mass is already given, which is 12 over 1,000 times v squared. So we have 2 here, this can go that 6, and then we have 1.2 is equal to 6 v squared over 1,000. 6v squared over 1,000. So we are multiplying 1,000 times 1.2. One decimal place. So we have 1,200 here. 1,200 is equal to 6v squared. Divide both side by 6. This goes. Then 6 here 1, 6 here is 2. Then we have v squared is equal to 200. V is equal to square root of 200, which will give you this in meters per seconds. Square root of this is 100 times 2. Then this is saying we can leave this answer in that form, like square root of 100 is 10. 10 root 2 meters per seconds. 10 root 2 meters per seconds. You can you can convert it to decimals if you want, and I am sure that you will give us a feedback or ask us questions in regard to work, energy, and power. Don't forget what I said. Make sure all units correspond before you begin to solve any solution in physics. I believe this will help you go a long way. Thank you for staying with us. See you next time on our next episode. Thank you.
Hello, my very correct people. They listen to us and watch us via Edu Radio. For this our studio, where they so we they give una waiting we feel say it go good for our children. I hope say una get or our children when they watch, when they listen. I hope say our teacher here when teach una, it teach una well. Our Facebook ID they here. Facebook.com/eduradio.ng. If you take meet us from there, communicate to us, talk. Our phone number anchor is here. Our Twitter anchor @eduradio.ng. Our YouTube anchor and Instagram eduradio.ng. Our website anchor where if you take see other things when don't pass every other thing. We they work with other organizations to give you education because we say education na key. Our website be www.eduradio.com.ng. Make we work together, and together we will take this education to greater height, where things like face mask, the kits will they import, the things will they bring in, we will begin manufacture them here. And through better and quality education, all of these things can be attained. Don't give up. Education, now our responsibility. Join hand with me next time. Or you fit listen to us for Love 104.5, Love FM, we're there for Abuja here, every Tuesday from 4:30 to 5 o'clock. Look, we meet there. Bye.